G'day guys. Today we're going to start working on the AI for these little pawns here. Now for this kind of game, the AI really does everything. We're not directly controlling any AIs, not telling this guy what to do necessarily. Mostly what he'll do is he'll have a list of orders that we've given. So we might say build a house over here, chop down these trees. That'll be added to a huge list of tasks that maybe this guy will do or maybe his mate will do. It sort of gets really complicated. It's going to be based on all sorts of priority lists, skill, what he's doing right now, whether he's hungry or not. Maybe he won't want to do anything until he's satisfied his hunger. It's super complicated, but what we're doing right now, we're just going to make one basic task, which will be cause him to find some food and eat it. And that will lay the foundations of our task system that we'll expand on later. So the very first thing we're going to do is make the task manager, which in this iteration isn't really going to do much of anything. But I'll add a child node here. It'll just be a regular node. This will be our task manager. And let's put these guys all the way at the top. We'll add a script to that. And we'll give it its class name, task manager. And the only thing it's really going to do right now is return a task once it's been requested by a pawn. And what we'll be doing here is just generating a find and eat food task, which is all this is going to do right now. Let's make that task. So this script is not going to be attached to anything right now. We're going to call it a task and just leave it as, inherits just a basic node. Create. Let's go find our task. Make sure we give it its class name. And that'll mean we can just generate it in the middle of another script. We'll create our task types. Okay, so by default, this will be the base task, but the tasks will actually be nested. Because I'm not going to write one huge task, which is going to tell him to do 6 different things. So I'm sorry, that should be find item, not find item. So we're going to have the base task, which is going to have nested inside it subtasks. So if we make a task that is find and eat food, the first thing he'll do is he'll find that item he wants to eat. Next subtask is he will walk to it. Then he'll pick it up. Then he'll eat it. So we'll just go var subtasks equals. Now I'm not sure if later on subtasks will have their own subtasks, but at least we're going to leave that open by having this being nested in this way. And we'll just remember which subtask we're currently up to. We'll also want to remember the target item for things like walk to, pick up and eat. And when we're saying find an item, we'll just be passing it an item type. And when the task is done, we need to remember if it's finished, or we need to be able to check if it's finished as we go. And the way we'll know if it's finished, which will be is we'll just return if the current subtask is equal to the lengths of the subtasks. So basically, when we're up to the last subtask, that means we're done and we can put this task away. I'll write one also just to force finish the task. And what that will do is it'll set the current subtask to equal the length of the subtask. So that will basically, if something goes wrong, say it can't find the item, we'll call this one and it'll just force it to go to the end and finish it. I'll put in a little script to get the current subtask. And so it'll just return subtasks, current subtask. Now, when one of the AIs finishes a subtask, what we'll do is we'll just iterate that current subtask. We'll just go on finish subtask, and that will just go current subtask plus equals 1. But we'll need some special ones as well. So that's the generic when we finish a subtask. But let's say we've just found the item, the func on found item. So this is for the find item task. We'll pass through the item and we will run on finish subtask just to iterate it by 1. But we want to store this item, because then when we're walking to it, we need to know where we're walking. So what we'll do then is we'll go get the current subtask, and we'll set its target item to item. So then when we finish the find item, it'll pass through that item to the walk to, and we'll probably pass it through to the pickup after that as well. But I don't want to pass it all the way up now because I want this to be more generic. But generally, if you've just found an item, whatever is the next task, whether it's pick it up, shoot it, whatever, it's going to need that item. So let's keep that there. And I'm just thinking, after we've walked to it, we need to pass the item here to pick up. So let's do that one now as well. Now, I'm not sure, because this gets called by the user, but not by the user, sorry. This gets called by the pawn, so it probably won't know the item. So what we'll do is we will do the same thing, but we'll actually grab it from the previous subtask. Now, I may regret that. That seems a bit wonky. I may regret that later, but it seems good for now. Oh, target. Item. So after we've reached the destination, pickup needs to know what the item pickup is. I could have it just look on the ground, but if there's like 2 or 3 items there, that's not going to work. All right, these are all the basic things the task needs to know. So what I'm going to do now is I'm going to add a function that will init a find and eat food task. So the plan is to have sort of a whole bunch of these. So if it's going to pick up weapon, this will do it. If it's going to harvest this, it'll do it. This may have to get more complicated later, but I think this will work for now. So the first thing I'm going to do is just set the task name as find and eat some food. And so that's applying to the current task. But then everything else is going to be a subtask. So we'll go var subtask and we'll make a task.new. So this is a new task, and its task type will be task type.find item will be the first one. Subtask target item type. Now, if you recall, I've got my item manager. We've got these item categories, and we can just use those directly. But I just realized we need to first give this class name. So now that there's a class name here, task manager. Sorry, that's item manager. I apologize. Item manager. We can go back to our task, and we go item manager dot item category dot food, and then finally we just subtasks. We append this subtask. So this first subtask, that is going to find us the item. And now the next one, if we find an item, we then need to walk to that item. We don't need a category for that one. That'll get its position from this previous one, so that's fine. So we find the item, we walk to the item, we pick up the item, and we eat the item. So that's how this sort of higher level set of tasks will work. It's got 4 subtasks: find the item, walk to it, pick it up, and eat it. And that's how most of our tasks will be. They'll have some sort of combination of those. So now all we have to do is go and teach our pawn how to actually do these things. Now, right now, our pawn just consists of this character body extension, which just really just handles the movement. All it does right now, in fact, it's just got some test functions, and then it can also follow a path. So I'm going to leave that like this. I don't want to pack everything all into one function. Sorry, I don't want to pack everything all into one method. So what I'm going to do is I'm going to attach a child node. I apologize, we don't do that here. And so what we'll do is we'll grab our pawn, and we're going to give him a new node. And this one, we're just going to call it, let's call it pawn AI. There may be more than one of these later on, but right now this one is just going to be about following tasks. Let's call that the pawn AI. And the first thing is he's going to need access to a few outside things. So he's going to need access to the task manager, which will be at task manager. We're going to need access to the item manager, and that will be so he can talk to the item manager and find items and get the closest one. we're going to need access to the character controller so we can tell it where to go. And that's just going to be ... because that's just one level up. I'm also going to add a new enum pawn action so we can track what he's doing right now, and there'll just be idle for when he's doing nothing. I just want one, we might have more later, but this is just when he's in the middle of doing a task, he'll do this. And let's actually make that doing subtask. So that means he's in the middle of walking somewhere, he's in the middle of doing one of those subtasks. And so we need to recall what is his current action. So his current action, its type is going to be a pawn action, and by default it's just going to be pawn action idle. We need to know what is his current task. So what we'll do is if his current task does not equal null, so if he doesn't have a current task, so if he has a current task, he'll do current task. And we'll pass through the delta to that as well. But then, or else, if he doesn't have a task, what we'll do is we'll go current task equals task manager dot request task. So if he's got a task, he'll do it. If he doesn't, he'll request a new one. And just to kill the error, let's go. All right, and that should be task manager. So let's go and just add this request task. We'll flesh out this request task. So he requests a task. For now, it's just going to make a new task. Task equals task.new. And we'll go task.init find and eat food task. And then we'll just return that task. So really simple for now. When he wants a task, it's always going to be a find and eat food task. So the only task we've got, so that's what he's going to get. All right. Needed that capital M in there. All right, so for the do current task, it's mostly going to be dealing with the current subtask. So let's just grab that from the start. So it's current task dot get current subtask. And this has to be broken up into a few little pieces. There's really three things. There'll be, when we first start doing a subtask, we'll do one function for that. So that will be start current subtask. Okay, so when we say do the current task, this function will handle all the recurring parts. This one will handle just the things that have to be done once. So what we'll do at the start is we'll just say, if the current action equals pawn action dot idle, that means he's not in the middle of a subtask. So we'll go start current subtask. And we'll do the ongoing stuff later. So let's say we're starting a subtask, we'll do the same thing. In fact, why don't we just pass this through here? So there's our subtask being passed through. And let's make sure it's working. So what we'll do first is we'll just print starting subtask. And what we can actually do, I could just go print subtask.task type, and that'll give me a number. But what I can also do is go item manager dot item category dot keys, which will give me a list of those different keys, and then we treat that number as the index, and it should print starting subtask and whatever the first one is, which was find item. Let's see if it works. So starting subtask food. So what I've just done is it's not item manager, item category, it's actually task manager. It's actually task.task type. I've just used the completely wrong type. There we go, find item, that's correct. So you can see it's looking at the first element here, which is find task. Sorry, find item. All right, now here's these two functions are going to do a lot of the heavy lifting. They need to know what kind of task it actually is and know what to do with it. So we're actually going to use a match case. So what we'll do is if the task type is task.task type find item, then what he'll do is we'll find that item. So target item will be item manager. So we'll use the item manager for this. Find nearest item. And the way that one works, we can go and have a look. The item manager, find nearest item, it takes the item category and a position and will return us the nearest item that it has. So we actually just go subtask dot target item type. So that should be food for this one, but it'll be others for others. So we're trying to make this as general as we can. And the position right now is the character controller position. Or we can even just go get parent dot position. But I think I'll use the character controller instead. Just in case this ever gets moved, we only have one reference we need to change. So if target item equals null, what we'll do is we'll just print no item force task to finish, and then we'll call that current task dot finish, which will kill the task. But otherwise, we'll tell our current task we've found the item and pass through that target item. And the only other thing we need to do is to let the AI know, so this current class know, no matter what happens, whether it finds the item or not, on finished subtask, on finished subtask, and all that will do is just say current action is pawn action.idle, and we'll also just say if current task is finished, then we'll just say current task equals null, and that will cause him to then ask for another task. Okay, now if that all works properly, what should happen is he'll find the food and he'll move from find item to the next task, which is walk to. And that's it, it's walk to. Now I'll assume he's found the right item. So the next in our list is what if we have walk to. Now this one's really simple. All we need to do is talk to our character controller, and we'll just say set move target, and the target's going to be our subtask dot target item dot position. So let's go and add this move target to our pawn. So it'll be a world position, type vector 2. Now we're going to do exactly what's been done here before. We'll get our current position and we'll just convert it to the grid, because if you recall, the position in the world is going to be by pixel, but for pathfinding, our grid is bigger. This is 0, 1, 2, 3. So to convert it, it's actually just multiply it by 16, which is how many pixels in one square. And we're grabbing that 16 from the terrain.rendering quadrant size, which is wrong, but it's working for now, so I'm not going to change it. And our target position, I'll just copy it from here. You see before we were using the global mouse position. Here we're just going to use this world position. And then we just set our path, which is just path equals pathfinding request path from the position to the target pos. So once we run this, it should give us a path. He should walk straight there. And I think we can just assume this worked. So we'll just go current task dot on finish subtask and on finish subtask. I've just realized I'm mixing up my capitals and my smaller letters, so let's go back and fix that. So did that break anything just now? Yeah. Now, if that worked, he should find the item and then start walking there. Just need to fix that capital T. We've got it. So he found the item, he walked to it, and now he's moved to pick up. Now we've actually got a problem in that it shouldn't be moving on to the pickup task yet. And the reason it's going straight there is because we never told it otherwise. So this is where we use our current action. So what we'll do, you got to go back because this is wrong. And then we just go action equals pawn action doing a subtask. And so what that will do is it'll prevent starting the next task and coming back into this method. So let's see what happens. You see he's grabbed it. We've started subtask walk to. He's walked to it, he's gotten there. And now what we need to do is add the condition which will tell him that he's there. And the way we'll do that is we'll just go back to our pawn, back to our character controller, and we'll just go func has reached destination. And the way we know that is by checking that our path has nothing in it. So if our path is an empty array, all right, has reached destination. And what we'll do, we've got our do current task. And right now we've just got it so that if we're currently not doing any action, we'll start the current action, or else in this section we'll have all the ongoing tasks. So in this case, it's just going to check to see if we finished there. So we'll make a match case here. So if we're doing a walk to, if has, I already forgot what I called it, has reached destination, then we'll just say on finish subtask and current task. So once we get there, what it'll do, it will finish this task, which means move on to the next one. And then on the next one, it'll grab the target item. So then we know what we're picking up in the next task. So let's just make sure that worked. See, and now we're trying to pick up. Let's pick up. So what we'll do, at the start of this task, we'll just call on pick up item, and the item we're picking up is subtask target item. Let's go and make that function. And then what we'll do is we'll make a in-hand variable just to hold the item while we're holding it. And we just go in-hand equals item. And then we'll go to the item manager and remove item from the world. So we'll remove it from the world, but it will still be in our hand. So we'll go to the item manager, and it's going to be the counterpart to spawn item. So we'll just go remove child, that item. And it's also in this items in world list, so we'll remove it from there as well. So that will take it out of the world. It will no longer be in our item manager. It won't be on the map anymore. It'll be in our hand, and this should be an instant thing, so there's no need to do anything else. We might have to put a check in later to make sure it actually picked it up, but let's imagine it all works well for now. And we'll just go on finished subtask and also current task dot on finished subtask. So that should pick it up. We should be moving to eat, and it should be gone from the map. Gone from the map, we've moved to eat. And let's just do one more thing. Let's just go to our next task. Let's just make sure it's actually in our hand. So I'm just going to print in hand, and let's see what we get. Oh, and let's also make sure we're doing subtasks, because eat is another thing which should take more than one frame. There we go, and you see we've got our simple meal. Excellent. All right, so now we've got to handle eating. Let's add some eating stuff to our pawn AI. So we're going to have our food need, should be a float. It started at 0.4. I'm imagining 0 is min, 1 equals max. Let's go bar eat speed. This will be how quickly we eat. Let's make it 0.5. Food need deplete speed. So this is how quickly our food need will go down. I understand I'm doing that a bit backwards, and 0.1 is really fast. But all these different things, I'm going to have them sort of start from 0 and go up to 10. So maybe there's a better word than food need. Anyway, I'm calling it food need. In our process, what we'll do, separate from the tasks, we'll just go food need plus equals food deplete need speed modified by delta. Now let's add one more thing. Because we can't really see that in game, I'm going to go to my pawn, and just now for testing, I'm going to add a progress bar. And I'll have this just temporarily show us that hunger. So hunger bar. Let's add that. Actually, this should be like that. And we'll also say hunger bar dot value food need multiplied by 100, just to turn the 0 to 1 to a 0 to 100. Let's just make sure that's working. We should see it going down. Yeah, wait, going up. This is why we test. That should be minus equals. All right, now, while we are eating, if in-hand.nutrition is a variable called nutrition, and what we'll do is we'll just drain that and add it to our food need. So if that is more than 0 and our food need is less than 1, we'll take away from the nutrition of that particular food by our eat speed. And our food need will go up by the same. And what we'll do is when it's done, I'll print finished eating food. I'll say in hand equals null, so that food is now gone from the universe. It's not in the world, it's not in the item manager, it's not in our hand, it's erased from the game. And then we'll just go current task on finish subtask, and on finish subtask locally as well. All right, let's give that a go. He eats. Okay, so he kept eating. What we should be doing, he's just grabbing the tasks as soon as he can. As soon as he's finished the first task, he moves on to the next one, because it is going right. If current task is finished, make it null, and then he's going back and saying, hey, I don't have a task, let's request a new one. So here's what I'm going to do. Just for now, let's make it only request a new task if the food need is less than 0.5. But that's just a test for the moment. So now he should only go and get food when he needs it. So he's full now, but he's getting hungry again. Obviously much faster than you would in the real game. There we go, he goes and eats. He has a rest, he gets hungry again, he's eating everything. He should go to this next one. Now I think it's going to bug out when we get to this bottom here, because what's happened? It's failed in the walk to. Oh, that will be because we've gone to find an item, haven't found one, but still gone to the next one anyway. So we haven't got a target item. So why? It should be saying no item, but it's not. So we're not getting null from our find nearest item. Let's go have a look at that. item. Oh, if there's no items in the world, it's returning false. It should be returning null. And if it's null, it'll just finish the task, and it'll, of course, instantly go back and ask for another one, but that's fine for now. Let me just go back and clean these guys out. So we'll only spawn one for now. He eats it, he'll get hungry again, and if everything works properly, we should just go into a loop of not being able to find a task. Yeah, no item, forced task to finish. That's great, and he'll starve to death. All right, so now we have our basic task management system. We can generate tasks. So most of our tasks will actually have some of these included. If we tell them to go pick up a sword, we'll be using the walk to. We'll be using the pick up. We might even be using the find item. So as we build it up, the fact that we've put these in all little separate little blocks should mean it's really extensible. And once we add a few more little things, the combinations will increase sort of, what's the word, geometrically, logarithmically. It's going to increase more than linearly anyway. So I'm not 100% sure that's the best way to do it, but that's how I've done it. But I'd love to get your guys' feedback. I've had some great feedback so far on some things that I could have done differently or even better. So let me know, and I'll keep working on this. Thanks a lot for your time, guys, and I'll see you next time.